Hello everyone, Saurabh this side, and in this video we will be covering the module 2, 3, 4, and 5. So let's start with the module 2. So the question and the first topic is data preparation, and here are some questions like how to add an index field, how to change misleading field, how to re-express categorical field, how to standardize numeric field, and how to identify outliers using Python. So let's start. First, we have to know what is data preparation. So in data preparation, it is nothing but more. It covers basically the data preparation techniques in Python, including an index field, adding an index field, changing the misleading field values, re-expressing the categorical field, and how to standardize the numeric field and how to identify outliers. Let's see them one by one. So first one is how to add an index field to dataset. So an index field can be added to a dataset by using the add row number function in the R or the reset index method. So this will assign a unique numerical value to each row and allowing for easy tracking and referencing in the index. Let's see it with an example too. So here is a Python program regarding this. So it is an original list. The list is having the items like apple, banana, orange, etc. Now adding index starting from 1. So here we have written list enumerate and original list was this and start with 1. So if we print index list, let's see what happens. So the output that comes here is 1 for apple, 2 for banana, 3 for orange, and 4 for grape. So you can clearly see that the index for apple has changed into 1, as we have mentioned here start is equals to 1. So this is what we call as the index adding in the dataset. Now moving towards the second one, how to change misleading field values. So modify misleading field values to ensure accurate analysis and interpretation of your data. So for changing these misleading values, we can use replace function. So let's see again in Python program. So here we have used the pandas library as well. So we can clearly see here the original list data here. It is a list of data and the modified data frame has been also given how to modify it. And if we have taken output, let's see what happens. So it is taking a lot time. So okay, so see here. So the original data frame was like this. Name, age, gender was this, and after modification, the name has does not changed yet, but the age has been given as NA because age cannot be negative. It will create an error because it is a time and time cannot be negative. So in that we have given an NA, that is user defined constant, so that it can easily be analyzed. So this has shown the misleading field values to change them. Now coming towards the third question, how to re-express categorical field values. Now so to re-express categorical field values, the factor function in the R language and map function or map method in Python has been used, and it is imported from pandas library, and this allows us to map the existing categorical values to a new standardized field values. So let's see it with an example or program 2. So the third one, first clear it out. Now we have already mentioned that pandas library has been imported, so let's see. Okay, so here the original data frame was like fruit were 0, 1, 2, 3, 4, 5, apple, orange, banana, apple. Now re-express data frames are like this: 0, 1, 2, 3, 4, 2, 1, 3. Like we have been re-expressing this. So this is what happened. Now coming towards the third, fourth one, how to standardize numeric fields. Now applying standardization techniques to numeric fields to eliminate variation in scale and improve model performance. Standardization techniques such as Z-score normalization or min-max scaling can be used to standardize numeric fields. So, for example, here in this program, we have imported the NumPy package, and you can see here the sample numeric field was given as 10, 20. This was a list. Now calculating mean and standard deviation, we have used the mean and standard functions here. Now now we are standardizing the numeric field using the z-score, and the formula for the z-score is here given. And now we are just printing the z-score and numeric original numeric field and z-score numeric field. Let's check it out. Now you can see that the original numeric field was 10, 20, 30, 40, 50 that was given in the program earlier, and the z-scores were minus, 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 0, 0. So this way we have finded out the z-score, which was the standardization technique. Now coming toward the fifth question, how to identify the outliers. So to detect and handle the outliers effectively and to ensure the robustness and accuracy of your data analysis, when identifying outliers, we can use the z-score method that we have already discussed. So let's see it within a program. So here we have used the NumPy package. We have to print the outliers, the data outliers. Let's print it. So when we run it, we will find out the outliers. So here we don't have any outliers, so it is giving a empty list. And if we were having an outlier, then it has shown the list of outliers too. So this was all about the data preparation for data analysis and analyzing. Now the second module is about exploratory data analysis. So the questions that are here are how to construct a bar graph with overlay, how to construct contingency tables, how to construct histograms, and how to perform binning based on predictive value. So here the first one is how to construct a bar graph with overlay. So visualize the relationship between two variables using a bar graph with overlay in Python. So in order to construct a bar graph, we have to use a plot.bar method in Python's matplotlib library. And this type of graph allows you to compare contrast and distribution of categorical visual variables across different subgraphs. Now we can see it here in our program too. So let's start with this program. So as you know that we have used the matplotlib for this. So if we run this, it is taking through time. So, so here we can see that the graph has been shown up, and this was the question that we have to construct a graph using Python, and this is all about this graph. So we have used here matplotlib.pyplot in order to generate or construct these graphs. Now let's move to the next one. So construct the contingency tables. Now to analyze and understand the association between categorical values using contingency tables in Python. Contingency tables are a useful tool for examining relationship between two categorical values. Now in Python you can use the pd.crosstab function from the pandas library, and these tables provide a way to summarize and visualize the joint distribution of the variables. Let's see it with the program and we will understand that too. So the second program is here. As you we have mentioned that pandas library will be used here display the contingency tables. So let's start it and run it. Although it takes some time, but you can see here in this, it has created a table, contingency table, like we have given smoker. So it has given no, yes, gender, male, female. It has given the table. So in this way, we have created the contingency table in Python. Let's move to our third question, that is construct the histograms with overlays. Now in order to construct an histograms in overlays, we will be using the hist function from matplotlib library in the Python and alpha parameter to control the transparency of the each histogram. Let's see it with example or program 2. So this is the program where we have used the matplotlib library to construct the histogram. So let's run it. When we are running it, we will see a histogram that will be formed. So like this, we can clearly see this is an histogram, and we have created this with the help of Python matplotlib library. So we can change the transparency through the function of alpha parameter. So this is what histogram looks like after constructing it with Python. Now moving toward the last question is perform the binning based on predictive values. So in order to perform binning in Python, you can accomplish this by using the pd.cut function from the pandas library, which provides the functionality. So for this, we have created the program, and the pandas library has been imported here. And when we are running it, let's see what happens. It basically takes some time because this. Okay, so here the binning table has been created. Features like predicted probability, now binned feature, and then target like low, medium, and it was also created that how many rows and columns have been given. So in this way, our third module has been done, and all the questions have been reached out. Now moving towards the fourth module, that is data preparation phase to model the data. Here also we have 5 questions like how to partition data, how to balance the training data, how to build CART decision trees, how to build C5.0 decision trees, and how to build random forest. So let's start this. So first, let us understand what the data preparation phase to model data means. So it is divided into 5. Like first one is the partition the data. Now dividing your data set into training and testing set to ensure that accurate model evaluation. And this can be done in Python using the train test split function from the skit learn library, which we have to import in our program. So let's test it in a program too. So here you can see that first clear it out the terminal. Here we have already see that we have imported the pandas, IMD learn and SK learn model. Now if we are going to run this program, then the output that it will be giving is in the form of tables like here. So we can clearly see here that the first name, gender, start, last date, login time, bonus, senior management, etc. has been given and provided. Now we have also used a file path, and the file path is 4.4 under employees.csv file. So we have using the CSV file which we have given to it. Like here we have given the data set in this CSV file. So it has used it and formed this table out of it and prepared the data. So let's move on to the second question, that is balancing the trained data set. Now address class imbalance in the training data set prevent bias and improve model performance. One way to address class imbalance in the training dataset is by using oversampling techniques such as synthetic minority oversampling techniques. So its example was also that first question 2 where we have created this dataset and we have formed the table here according to that data preparation. Now moving towards the third question, that is build a CART decision tree. Now creating a decision tree using classification and regression tree algorithm in Python. Now to build CRT decision tree in Python, we will be using the decision tree classifier from the scikit-learn library to build this. Now let's see it with the program. Here you can clearly see we have imported the pandas library, sklearn model, and every library that we have been using, and we have also used the CSV file, that is this. We have also used this in our program. So let's run the program and see what happens. So we are running, the output that it is getting is the decision tree. So it will basically create a decision tree for us. So let's wait. Let so you can see here that created a decision tree like marital status was the root node, then this marital status, then this, basically created a decision tree as you can see here in the output terminal. Now moving towards the fifth one, that is building a fourth one, building a C5.0 decision tree. Now to build a C5.0 decision tree, we will be using a C5.0 classifier function in the C50 package, can be used in the Python. So let's see it in the program. Here, as we have seen, it is created an error like rpy2 is not in. Let's see what happens. What is the error? So here error is giving that rpy2 is not installed. So let's install it. Pip install rpy2. Wait for a minute. So it is creating an error. So we will be stopping this because we will see it in afterwards. Now moving towards the fifth one and the last question of this fourth module, that is build random forest. Now develop powerful predictive models by building random forest in Python. So in Python we will be using the random forest classifier class from the scikit-learn library to build. This class also provides the flexibility to define parameters like the number of trees. Let's see it with an example. So here is the program that we have been using. Here we have been importing the pandas library, the sklearn, and every other library that can be used. The random forest classifier, etc. functions are used here too. So you can see here that it is given 7 divorce and one single name object has given all this, and here we have also used the CSV file that this for tree sample so that we can get the data. So now our fourth unit, fourth module has completed. Now the fifth module and the last module is model evaluation. Here you can see, and there are two questions: how to perform model evaluation and accounting for unequal error cost. So Let's see it. So first one is perform model evaluation. Now, evaluating the performance and effectiveness of models using various assessment techniques in Python. And in Python, you can leverage libraries like scikit-learn library to perform this assessment. And these techniques allow you to measure the accuracy, precision, and important metrics of your models. Let's see it in the program. Here we have used the scikit-learn libraries and classification, report, function, etc. So let's run it. As the output, you can see that it is giving a confusion matrix, accuracy, classification report in the form of table, and accuracy, macro average, and weighted average also has been given in this program. So in this way, we have performed the model evaluation. Now, second one is accounting for unequal error cost. So consider the impact of unequal error cost when evaluating models and making decision in Python. And in this can be done using cost sensitive learning techniques in both R and Python too. So by incorporating these step cost into your evaluation framework, you can make more informed decision based on the specific context and requirement of your project. In this way, we can account for unequal error cost. Let's see it within program. In this program, we have been importing the sklearn model selection, sklearn libraries, etc. So let's run it and see what is the output here. Here we have also given this list of the data. You can see here it is also given the confusion matrix, then classification report of this model, that how much precision it giving, recall, what is the F1 score and what is the support score. So in this way, we have been creating the programs for the model evaluation, that how precise and how accurate your model is trained and can give the answer or result. So that's all for this video.